the Antarctica is in fact gaining more ice than it is losing.
One of Greenland's most observed glaciers shocked scientists recently. According to NASA, it has gained ice, despite being the world's fastest melting glacier.
We are expecting things to be colder, not getting warmer.
Climate change has sparked a major debate amongst top climatology experts on how weather patterns are being affected by rising surface temperatures, but it appears not all experts agree on how this effect is happening. As it turns out, we were wrong. The North Pacific is cooling and Antarctica is growing. Weather patterns have seen some remarkable changes in the past decades, something which many might attribute to climate change, but as it turns out, experts disagree that these changes might not be caused by climate change at all. One of the major countries that sits right in the middle of these fluctuating weather changes is Australia. The country has been drastically affected by the famous La Niña winds, resulting in major flooding and cooler summers on the country's east coast for the past couple of years. For those of us who might not be conversant with the La Niña weather phenomenon, let's break it down for you. La Niña is a major part of a natural climatic cycle that blows cool air over the tropical Pacific Ocean. It is one part of a larger cycle, with the other part being El Niño, which blows much warmer winds than La Niña. Both weather events alternate effects on both ends of the central and eastern tropical Pacific, with sea surface temperatures varying between both events. Both weather events are collectively called the El Niño Southern Oscillation, or ENSO. The varying effects of La Niña and El Niño have monumental effects on weather patterns, bringing severe tropical rains and floods to one region while simultaneously bringing droughts to others, and the cycle shifts. Although the climatic effects and impacts of ENSO are largely felt in regions around the tropical Pacific, these effects can very well extend to any part of the globe, making ENSO the prevalent force in driving global interannual climate variability. The effects of ENSO on precipitation and temperature change are prominently felt around East and Southern Africa, Southeast Asia, Western Americas, Australia, and Antarctica. Of all these locations, Australia has seen more La Niña events in recent years, and the most recent flooding has been a result of the third La Niña event in a row. 3 La Niña events in a row is incredibly rare, as these events tend to alternate annually, with warmer El Niño events expected to follow a single La Niña. Some experts have chalked it up to increased surface temperatures, which have a varying effect on the regularity and intensity of these climatic events. But other experts and researchers have stated that however rare the 3 consecutive La Niña events are, they are not impossible or unheard of. There has been a recorded string of La Niña events which happened between 1974 to 1976, as well as 1998 to 2001. La Niña carries colder winds from the eastern and central Pacific, blowing towards parts of eastern Australia, which have accounted for the wet and cold conditions the country has experienced in the last 2 years. On the other hand, El Niño events have been causing severe droughts and dry conditions in the southwest United States and Latin America. The National Bureau of Meteorology has stated that this predicted third La Niña event may be weaker and short-lived compared to the first 2. Although this will be good news in terms of rainfall intensity, it still spells unfortunate news for those in East Australia who have barely recovered from the last strong rains and flooding in that part of the country. The last 2 La Niña events released intense rainfall, leading to full water catchments and sodden soils that need time to dry up. These projections spell bad news for residents in affected areas in East Australia like Queensland and New South Wales that are still trying to recover from intense floods from the previous season. But the main question remains, what have these events got to do with climate change? And do greenhouse gas emissions affect the intensity of ENSO events, if at all? Experts studying the varying effects of ENSO events such as La Niña and El Niño have stated that it's still unclear how these events will be affected as the surface temperature on the planet warms. But there has been some evidence which might state that climate change might actually impact the frequency and duration of these ENSO events. A research paper studying the connections between events like La Niña and regional climates in highly affected Pacific areas like Australia was published earlier this year. The paper detailed that an increase in surface temperatures due to greenhouse gas emissions could further intensify the frequency of ENSO effects in most parts of the country. In studying the effects of La Niña events in recent years in Australia, experts found that there are more climatic forces at work that determine the intensity and frequency of both rainfall and drought. These two forces are naturally occurring climatic factors, which include the Southern Annular Mode and the Indian Ocean Dipole. The Indian Ocean Dipole is characterized by an oscillation of variable sea surface temperatures, whereby the western Indian Ocean becomes relatively warmer and the eastern pole of the ocean becomes irregularly cooler. This change between warm and cool sea surface temperature rotates, with more rainfall in cooler parts of the ocean and droughts on the warmer end of the ocean. The Southern Annular Mode, on the other hand, is a low-frequency mode in which atmospheric variability causes changes in pressure and movement of powerful westerly moving winds surrounding Antarctica. These winds are positioned in the lower southern hemisphere and play a huge role in affecting the weather systems and winds in the southern parts of countries like Australia. These two distinct climatic factors in combination with La Niña make a relatively hot and dry Western Australia colder and prime for heavy rains, which is what we've seen these past few years. All three climatic factors have also been prominent in the past, with the previously recorded occurrence taking place in the spring of 2010, when Eastern Australia experienced a similarly high record of rainfall. Although the 2010 phenomenon was a one-off event, it appears the current trend of La Niña events may induce more rainfall in the coming season and hence trigger more flooding. Although the projections may indicate the likelihood of another La Niña event, it is still uncertain which parts of Australia will be affected. One thing is for certain, though: the combination of La Niña events, the Southern Annular Mode, and the negative Indian Ocean Dipole will most certainly spell unfortunate news for some parts of the country. But the effects of these climatic factors doesn't mean all bad news for residents of Australia, as cooler climate temperatures and regular rainfall mean instances of drought will drastically reduce. In fact, some of the worst droughts on record in Australia have been the direct effect of the lack of La Niña and negative Indian Ocean Dipole conditions in recent years. With Eastern Australia experiencing 2 consecutive La Niña events, the region is unlikely to experience any severe droughts in the near future. These cold, wet effects of La Niña on the region also reduce the likelihood of severe bushfires, which have plagued many parts of Australia in recent years. But then again, Mother Nature will not be denied, because although more rain means fewer dry plants for bushfires, it also means more green plants which will multiply or definitely dry out in the future. This could provide more fuel for fires in the distant future once the dry hot conditions return with the warmer El Niño event. However, one major benefit of La Niña is that the cooler and wet conditions it brings normally reduce the global mean temperature by cooling a higher part of the Pacific Ocean, which happens to be one of the hottest regions of sea surface temperatures in the world. But this global cooling effect is generally temporary, and continuous greenhouse gas emissions tend to raise the temperature back up, especially when the warmer El Niño event comes into play. A lot of Australians have been asking if the continuous trend of La Niña events could very well spill over to a 4th consecutive La Niña, but experts believe they have no reason to fear so. This is predicated on the fact that however rare a triple La Niña event is, we've seen it in the past, but there has been no record of a quadruple La Niña event in history. Experts have warned that for now we must contend with the current La Niña events, but also mentally prepare for the unlikely scenario that Australia sees yet another season of cold climates and steady rainfall. The effects of ENSO events have been correlated to the effects of climate change and the rise in the planet's surface temperature, but the main concern is how these effects will reflect future changes. But before we jump into any conclusions on how and when ENSO events will affect global climatic weather conditions in the future, we must take into account how these events have unfolded in the past. We need to understand if ENSO events are indeed changing in response to greenhouse gas emissions. So let's take a quick look. Well, according to climatology experts, ENSO has changed, but also hasn't. This might seem a bit contradictory, but bear with us here. According to expert data, the amplitude of ENSO events as well as the frequency of each occurrence has increased slightly since the 1950s. This increase has been in slight contrast with the recorded occurrence of ENSO events between 1850 and 1950, and even as far back as the 15th century. A report by the Intergovernmental Panel on Climate Change, or IPCC, noted in a published report that the increased number and intensity of El Niño events in the last 20 to 30 years might be a result of the increase in temperature levels across the Central Pacific. But although the report states the correlation between temperature and fluctuations of ENSO events, it was clearly stated that it does not necessarily mean that human-induced climate change is behind the fluctuation in these events. Scientists were able to track the occurrence of ENSO events as far back as thousands of years using the instrumental record and paleoclimatic proxy evidence. These paleoclimatic proxy records are sources of data that show us the climatic state of the Earth during a particular period in the past. These records are obtained by observing the growth and evolutionary traits of ice cores, tree rings, and sediment deposits in lakes and seas. A study of these records indicates that throughout the last 11,000 years, ENSO events have fluctuated and demonstrated varying amounts of patterns and amplitudes. This tells experts that there is indeed no clear indication that the changes we've seen in ENSO events since the 1950s are peculiar or resulting from climate change. In addition, climate model simulations have indicated similar fluctuations in attempts to predict the patterns of ENSO events in the future. These simulations have both included and excluded the effects of greenhouse gas emissions, all of which have produced varying results regarding the future state of ENSO events on the planet's climate. Also, a detailed study of the recent trends of ENSO events around the Central Pacific has indicated that any changes in frequency and intensity of these events may very well be within the normal range of natural variability. Apparently, this might simply be how the Earth works, in unpredictable patterns of highs and lows that might not be directly correlated with the effects of human activities and greenhouse gas emissions. A report by the IPCC does not indicate any consensus regarding the change in sea surface temperatures over the next centuries in relation to greenhouse gas emissions. But regardless, one thing is for certain, it is very likely that the variability of rainfall over the East Central Tropical Pacific will increase significantly over the next few years. It is also important to make a distinction that climate models are not saying there will be absolutely no changes in ENSO events over the next century. Some models actually indicate some changes, but the main issue remains that some models do not indicate any change at all, and there is therefore no common consensus to display 100% accuracy on future weather patterns where sea surface temperatures and ENSO events are concerned. This concern is also evident in the changing ice patterns and winds that have impacted the growth of ice in and around Antarctica. Experts have indeed observed that there has been an expansion of the ice sheets on the eastern Antarctic Peninsula since the start of the 21st century. The research was carried out by a team of climatologists from the University of Cambridge in the United Kingdom and another team from Canterbury University in New Zealand. Both teams found correlating evidence that floating ice sheets on the eastern and Tattered Peninsula have grown significantly between the years 2000 and 2019. They employed the use of satellite imagery and measurements dating as far back as 60 years in addition to atmospheric and oceanic records for better calculation and understanding of the detailed expansion of ice conditions around Antarctica. The study was primarily around a 1,400-kilometer-long stretch of ice peninsula. Both combined records showed at least an 85% increase in the ice shelf around Antarctica since the early 2000s. In 2019, the team made an expedition to the frozen continent itself and found that ice sheets close to the coastline had advanced significantly since satellite records began observation in the early 1960s. The expansion in the ice sheets around Antarctica are highly unusual this late in the 21st century, especially where there have been recorded patterns of melting ice in both the North Pole and other areas of the polar ice caps. This has also compounded the level of conflicting results, with some experts indicating that there will be a significant ice loss to the polar ice caps, while others indicate there might very well be significant ice gain as the century unfolds. One thing that is certain is that ENSO events are a highly complicated concept between oceanic surface temperatures and the atmosphere, a dance that has a significant effect on global weather patterns. A simple explanation as to how complex ENSO events are is taking, for instance, that the light bulb in a room represents an ENSO event, but that singular light bulb is controlled by multiple switches, all of which represent oceanic wind, sea surface temperatures, greenhouse gas emissions, and other climatic factors. It is nearly impossible to determine which one of these factors has a different effect on how ENSO events unfold, if at all. Also, the long-term effects of ENSO events over the last 1,000 years don't make pinpointing an exact pattern any easier. However, there is still research ongoing that might shed definitive light on how climate change might unfold over the course of the century.